Alright, so welcome to Solving Inequalities with Variables on Both Sides. This is in Chapter 3, Section 5 of the book. And we're trying to solve inequalities that contain variable terms on both sides. So not something that should hopefully be very hard. Kind of follow the steps here, and it hopefully should be very easy. So let's look at the first example on this, because honestly this is something that you should be able to work on. Now, my advice is I like to go variables to the left, numbers to the right. So kind of keep that in mind. So here I see x less than 3x plus 8. I want to move the 3x over to this left side to be on the same side as the x. So I'm going to subtract 3x. And then I'm going to get negative 2x is less than 8. Then I can divide by 2, negative 2. And keep in mind, I'm dividing by a negative, so that means I'm going to have negative 4 here, but I need to make sure I switch the inequality and graph accordingly. Open dot now shaded to the right. Okay. Any questions on that, feel free to ask. Send them to me on Edmodo if you need to. Next example. 6x minus 1 is less than or equal to 3.5x plus 4. Now for me, like I said, notice here, there's no multiplying, I'm sorry, not multiplying, there's no parentheses, so no distribution, no combining like terms. You're going from one side to the next. So I'm kind of keeping that a little bit easy. So I'm going to add 1 to both sides. Then I'm going to also subtract 3.5. 1 plus 4, by the way, is 5. Y'all should know that. Minus 3.5x. 6 minus 3.5 is 2.5. And then I can divide by 2.5 to get x is equal to 2. I'm sorry, is less than or equal to 2. So put a closed dot at 2 and go to the left. And there you go. So again, hopefully most of these should not be that difficult. You're just trying to do something like that where you're like adding and subtracting the number to get it to the right, add and subtracting the x or whatever variable you have to get it to the left. Alright, on page 195 of the book, there's an example here, and I wanted y'all to see this example that says the daily info charges a fee of $650 plus $80 per week to run an ad. The People's Paper charges $145 per week. For how many weeks will the total cost at Daily Info be less expensive than the cost at People's Paper? The idea here is that they're trying to say, okay, look, initially you're going to pay more at Daily Info, but you notice that you're being charged less per week. So is there a way that we could find how long I would have to keep my ad at the Daily Info to get a lower price? Well, let's start setting this up. You're paying $650 plus $80 every week. And you want that to be less than, okay, and that's at the Daily Info thingamabobby. You want that to be less than the $145 that you will pay every week at the People's Paper. So, how do we solve this? Now, against my better judgment, this is, actually, we're going to do it this way. I don't like the way this is written, so what I would do is this. I would go ahead and rewrite this as 145W, flip-flop these. You can do that as long as you keep everything pointing the same direction. Okay, and then what would I do? Well, I want to move this to the left side. So I'm going to subtract 80W. And get, see here, 65W greater than 650. Then divide. And get W is greater than 10 weeks. So what does that mean? It means that basically if you want to have, when the ad, you paying for an ad at the Daily Info will be cheaper is when you spent 10 weeks, or you paid for 10 weeks, or go more than 10 weeks, then you're suddenly getting a better deal at Daily Info. Under 10 weeks or under, it's going to be a better deal at People's Paper. So you basically are trying to make sure you spend at least 10 weeks. Or more than 10 weeks. Okay, on page 196, they talk about identities and contradictions. An identity is when you solve it, you will have, say, a true statement, but your x is gone. A contradiction happens when your x is gone, but you have an untrue statement. Okay, when it's an identity, every number, you could put any number you wanted into the original equation and it would work. So every number is a solution. A contradiction no number is a solution. Nothing would work. Okay, so that would be the big difference between the two. So let's go ahead and do that problem. Let's see here. We have an example. X plus 5 is greater than or equal to x plus 3. So I subtract 5, or subtract 1x first, I guess. And I can also subtract 5, going based on the way I like to do this. The x's, the 5's, and the 1x will cancel out, leaving me 0 is greater than 2. Greater than or equal to negative 2, sorry. Which is a true statement. That means that's an identity. And that means any number I were to put into that original equation would be a solution. So all real numbers are solutions. When you say identity, all real numbers are solutions. And then on the last one, this example, excuse me, 2x, I'm going to subtract 2x's, and I'm also going to subtract 6. When I do that, I end up with 0 is less than negative 1, which is not true. So that's a contradiction, which means nothing would work. No real number is an answer. No real number is a solution. So basically, it's like a messed up problem, I guess you could say. So anytime I tell you this, like if I ask you like what are the answers and you get in contradiction, you're basically saying no real number, so no answer. Whereas on the other one, where I said here, identity, all real numbers are your answers. That's solving with variables on both sides. If you have any questions, feel free to ask. Thank you very much.